It's the Introduction to Computers. It's Tuesday. We're in week 14. 2 weeks left. We talked a lot about information systems today. So, we started out development of information systems. We talked about that system development life cycle. The whole idea that systems have life cycles. You know, you develop them. It's like a human being. We're a system. We have a nervous system, respiratory system. We have lots of systems that keep us functioning. We start out, we're born, we develop, we become productive, and then eventually we die. So we go through a life cycle. Information systems are the same way. Lots of systems are the same way, even the development of cars and so forth. But here we're talking about development of information systems. We have two ways to approach this. We have a top-down, where we analyze we go through all these things to make sure the system works. And then we have a bottom-up, in which we create a prototype, and then we build on the prototype until we get a system working. This is good for some cases, but is not appropriate for others, in which we need to do a really good analysis and design and development, because a system can have flaws in it, like an air traffic control system or the 911 information system, or we could name the power grid systems, all those information systems that need to work, that lots of lives depend on. All right, so we investigate. Define the problem. I use the word problem, lack of a better term. We want to solve something. We want an easier way to do something. We write checks. Back in my day, it was either cash or checks. Nowadays, we can use debit cards. Well, in order to use debit cards, we need an information system in order to manage that. Okay, so that's just one simple example. There are literally thousands of how we function now because of information systems that we didn't function before. And again, the information system is an idea of how do we get the data to move through so that the people can get the information they want. And we worked on that the other day. So you define the problem. You have an investigation. Then you analyze, and you get lots of feedback. An example I use is building a house. Why are you going to build a new house? Well, we've got a big family, and we don't fit in the house we're currently in. Okay, so then what kind of house you build? Well, there's lots of things that go into analysis. How many bathrooms, how many bedrooms, how much can you afford, where do you want to locate it, et cetera, et cetera. So you decide all those things with lots of feedback. You know, you have somebody maybe draw some plans or sketch out some things and feedback. Then eventually you get the part where you're going to design it. Now in information systems, this is huge. You design the whole system. You can use flow charts to decide what information is going to flow to who within the system and how people are going to access that information. Once you get the design done, this is really the huge part right here. Getting through these and making sure, getting lots of feedback from lots of people to make sure you got it right. Because once you start developing it, you're either going to buy software or design software or some combination of those that will actually make the whole system work. Okay? Once you get it designed and developed, you get all the software in place, you get all the equipment in place, then you have to decide how you're going to implement it, how you're going to start using it, how you're going to put it into use. You can phase in different parts, make sure they work. You can run a pilot, like run it in one store or one location, see how it works. If it works well, you take care of all the problems, and then eventually you can do a cutover, or you can do a cutover right away, in which you get rid of the old system and use the new system. You have to be really careful with that and make sure that it's going to work, or you have some backup if it doesn't work. Once the system's up, you have to evaluate to see if it's actually doing what you want it to do. Is it really solving the problem? And then you have maintenance. You have updates, you have fixes. You know, when people develop software, it basically goes through the same steps. You have a problem, you analyze it, you design the software, you write the software, and you implement it. And then this takes us back up to investigation again. You know, when you have an issue, you need to have maintenance, or it doesn't do exactly what you want. You look at how can we patch it, how can we fix it, analyze that, design it, write the software correction, and implement it. This happens all the time, like with operating systems on your computer. You have updates from Microsoft. That's kind of going through these steps. Now, a bottom-up approach is you go through these steps very quickly, and you start a little bit of the development almost right away. I use the example in class of creating a PowerPoint. Nobody, well, I say nobody, but I'm pretty sure most people don't draw out by hand all their slides first, and then figure out exactly what order to put them in, and then type it in the computer. Typically, you create some slides and build it on the run. This works really good for a lot of situations, simple information systems and so forth. You can do it much more inexpensive way of approaching it, or it's much faster. You get to a product faster, but a big issue is if it happens to have a key flaw in it somewheres, you might have to start completely over. So some systems like air traffic control, we can't create a prototype and start running it and see if it works and then have several planes crash and then say, you know, that's not going to work. We can't do that. You can't do a prototype for something like that. You got to do a top down. You got to look at the big picture and break it down into parts in order to be able to design it. Now, this part right in here, the development, where we design the software. You can buy software packages, write them yourself, or there's some in between. You can buy stuff that's designed, like a database system design, and then you can manipulate it to do what you want it to do, similar to what the college does here with WebAdvisor. They bought the base package, and then they design and change it to do what they want to do. If you're going to write software, you're going to program software, first thing you do, if you're going to write a program, you have a purpose. What's the program, what problem is it going to solve, or what's it going to allow us to do? And then we have the steps in order to write the code. Two different types of software out there. We have proprietary, that's written and designed and owned by somebody. Then we have open source, not owned by anybody. And people can go in and adjust or change it. We clarify what the word source means on Thursday. Problem to solve. Get all the specifications, exactly what you need. Design the solution before you ever start writing code. Make sure you know what you want for the solution, and then you can literally write the code. Write the program using some programming language, and we talked about C++, Python, Perl, PHP, Fortran, Cobol, Pascal. There's all kinds of programming languages to write the code. The code then is converted into executable code, we'll talk about on Thursday. You test the program, make sure it's working, and then you document it, documentation for the program, and then there's always maintenance. Little things that didn't work right or need adjustment, and then you create updates to the software. And that's an ongoing process at Microsoft, creating updates for their software. Okay? And that'll be it for today.